Hello and welcome. This video is going to walk you through the answers to the Chapter 4 practice test. So basically what I've got here is a Word document with the key, basically a detailed key. And so I'm just going to walk through each question here. So question 1 is a Z for a sample mean problem, and I always recommend that you start off by writing down what you have been given. So identify the sample mean, the n, the population mean, the standard deviation of the population. Then write your formula, substitute in the proper values, and then find your z. There's your answer. And then for question number 2, you're essentially doing the exact same thing with some different values for a different population. Substitute those in. Here are your answers. Then for question 3, it's asking you which group did better. And of course, what you're doing here is you're just comparing the two z-scores. This is the group. The stats group did better because their z-score is bigger than the z-score for the history group. Both z-scores are pretty impressive, by the way. If you're more than 2 standard deviations above the mean, you're rocking it. Okay, and now for question 4, you're asked to find the probability of getting a z-score of 3.1, which is your answer for question 1. This is you dealing with the same data from question 1. So the first thing you should do is draw the curve. Here's the curve. Locate where 2.31 is. There it is. Then you got to go to, because this is a z, you can go to Appendix A and you find 2.31 right here. And because this is a tail, because the question was asking getting that p-value or higher, so it's a tail. So your 3.1, you want the tail. There's your p-value. On the key, or on the question you're asked, the option you're given is 0.01, and here's why. We just didn't carry out all the digits. Okay. So question 5 is a little bit of a maybe a challenging question. I remember getting some questions on this. So it's asking you which of these is more likely to happen, to get a random sample of 27 students that have a mean of 26, or a random sample of 100 students who have a mean of 26. The important thing to remember here is that the population parameter is 52. So you really do expect both sample means to be close to 52, but you would expect the sample mean coming from a sample of 100 people to be closer to 52 than a smaller sample of 27. So given the options here, a smaller sample size of 27 is more likely to be close to 56, which is again far away, relatively far away from what we would expect, or the population parameter of 52. Okay. Number 6 is asking you to compute the standard error of the mean, or the expected sampling area that you would expect when you have a standard deviation of 9 and a sample size of 27. So you substitute it in, and there's your answer. Number 7 is asking you to decide which of these options is the better description of a distribution of sample means. Well, there's 3 things you need to be looking for. The correct answer is going to identify, correctly describe that it is all possible random samples of a specific size. That's what people typically forget. And what specific size? Well, it's the sample size. So it's all possible random samples of the sample size that you chose, in this case 36. Also, the mean that it identifies in the answer should be the population mean, and the standard deviation that it identifies should be the SEM, or the standard deviation of, I'm sorry, this should be the standard deviation of the population. Let's just go ahead and change that now. So it's the population standard deviation by the square root of n. That's what's going to be, that's why this is 2. If you work out those parameters, right? So it would be, in the question, the standard deviation is 12. So it'd be 12 divided by 6. Because 36 divided, the square root of 36 is 6. So that's why it's 2. Okay, and number 8 is basically to talk about what types of properties does the central limit theorem give you for the distribution of sample means. And it gives you all of these. It gives you the shape, the central tendency, and the variability. And then 9 asks you, what's the center? Well, the center is going to be the population mean, or mu. Mu is what was given as your option for number 9. And then number 10 is asking you to identify the standard deviation of the distribution of sample means and select all that apply. So the standard deviation of the distribution of sample means is talking about the variability. So it's talking about this, the standard deviation. Again, this would be the population standard deviation again. I mean, it could be the sample depending on what you're working with, but no, it would be the population standard deviation. Sorry. Then it would be, the other thing it would be is the standard error of the mean, because that's basically what this is in words. And now moving on to 11. 11 is asking you to talk about the shape. And the shape, again, is going to be normal under 2 different conditions. It's going to be normal if the original population has a normal shape, or it's going to be normal if the sample size you're dealing with is pretty large. Basically, if it gets close to 30, it's pretty much a normal distribution. Okay. And larger samples will produce a more normally shaped distribution than smaller samples. That's 12, and then 13. The standard error is a measure of sampling error. Right there. And I mean, I have a little curve here to sort of describe that, but I don't even know that we really need it. You just need to remember that the standard error of the mean is a measure of expected or typical sampling error. And it's reflected in the figure here. These steps, the size of these steps, one up and one down, though the size of those steps is determined by the SEM. But again, we'll talk about that more in the next chapter. We don't need to go into it here. How is the standard error influenced by sample size? Again, kind of referred to above, larger samples have less sampling error, so a smaller SEM. And I've demonstrated that here. If you have a standard deviation of 10 and a sample size of 25, the SEM is going to be 2. But if you have a standard deviation of 10 and a sample size that's 4 times bigger, the SEM is going to be half as large. Okay, now 15. 15 is asking you to find the point estimate when you are given the certain values here. Well, the point estimate is the difference between the sample mean and the population mean. So in this case, it was 75 minus 69, so that gives us 6. 16 is asking us to compute the margin of error. And so you need 2 terms to compute the margin of error. You need the Z critical confidence, the Z for the confidence interval, for the 95% confidence interval. And that is always 1.96. And the SEM is, again, the standard deviation divided by the square root of n. So with the parameters that you're given here, the sample size was 18, and the standard deviation was 10. So if you work that out, that's what you're going to get. And so there's your margin of error. Then to find the upper bound and lower bound, you simply take the point estimate and subtract the margin of error to get the lower bound and add the margin of error to get the upper bound. If you do that, here's what you get. And then this CI is this confidence interval is the range of plausible estimates of the mean difference between the honor students and the population. So again, this is how different might these two groups be. On the lower end, they might be different by about 1 point. On the upper end, they might be different by about 11 points. So again, those are all the range of plausible mean differences between these two groups. 19 is asking you to, again, work with a confidence interval question, but this time you have to use a T curve rather than a Z curve, and that's going to influence how we compute the margin of error in question 20. But it does not influence how we compute the point estimate. The point estimate here is, again, the difference between the sample mean and the population mean. So if you find those numbers, it's 44.5 minus 40. That gives us a point estimate of 4.5. Now, to compute the margin of error when you're doing a T, it's slightly more complicated. You can't just memorize a number because the TCI is not always the same number. It changes. And you have to find that. I wanted to put in a little graph or of a picture of Appendix B, but I couldn't easily find a graphic that I could insert of Appendix B. So you're going to have to do it without the picture here. You're going to have to go to Appendix B, and you're going to need to know what the DF is. Well, the DF is the sample size minus 1. So in this case, the DF is 35. So you need to go to Appendix B. You need to make sure that you're using the two-tailed table. There's two tables back there. Make sure you use the two-tailed table. And then when you get to the right table, find the DF of 35, and then under the 0.05 column, you will find the TCI that you need. There it is. Then you compute the SEM the way you have many, many times, and there's your margin of error. The next step for 21 is to actually compute the upper bound and lower bound. And again, you just find the point estimate, subtract the margin of error to get the lower bound, add the margin of error to get the upper bound. There are your values. And then the last several questions are dealing with how to pick what statistic to use. It's really not that complex at this point. What you're looking for is the question asking about a sample mean or not? If it is asking about a sample mean, then it either has to be a single sample t or a z for a sample mean. And the way you decide between those is whether or not you know the population standard deviation. Not just any standard deviation. You have to read the question. It might say the standard deviation is 7, but you have to know, is that standard deviation 7 of 7? Is that a population standard deviation or not? If it's a population standard deviation, then you would be able to use a z for a sample mean. Now, if a question doesn't ask about a sample at all, then you know it has to be a z for an individual score. So using that logic, these are your answers for questions 22, 23, and 24. Obviously, if you have any questions on any of this, feel free to ask your instructor and enjoy.